You're looking at complementary angles that have a ratio of 5 to 4. You have 5 parts and 4 parts. So how many total parts are we dealing with here? 9. Okay, so the larger angle is 5 of those 9 parts, and the smaller angle is 4 of those 9 parts. Right? And so we're taking some percentage of the whole thing. Well, when we're dealing with complementary angles, we know what the whole has to equal, right? What's the sum of complementary angles going to be? 90. So all we need to do is calculate. 9 goes into 90 10 times. 10 times 5 is 50. 9 goes into 90 10 times. 10 times 4 is 40. So here's our two angles, 50 degrees and 40 degrees. They are complementary. They add up to 90. They do have the ratio of 5 to 4. Okay. Right, now, if you're somebody who solved it in the idea of part to part, you probably solved it more visually, and working with complementary angles, the easiest visual way to set it up is just create a right angle, a perpendicular, and then label what you have. So the one part is 5 times some common multiplier. The other part is 4 times that same multiplier. And you know that the total sum of those has to be 90 degrees. So we can use angle addition here to find 4x plus 5x is equal to 90. Combine our like terms. Divide by 9 to solve for x. And once you solve for x, you can plug it into each of these forms. 5 times 10 is 50. 4 times 10 is 40. And again, talk about the way that I would probably say is the easier of the two ways, or the quicker of the two ways for this type of problem. The limit on it is this method only works for a specific type of problem. And then I'm going to go through a little bit longer process, but it's a process that's consistent with any problem dealing with complements and or supplements. So the first method can only be used with example 2. The second method I go through can be used in both example 2 and 3. Okay. All right, so the first method that we can approach this is looking at it kind of holistically. Look at the entire problem. The entire problem says you have two complementary angles with a difference of 12. So what that means is if one of your angles is x, you can add that to the other angle and get 90 degrees because we're dealing with a set of complements. So how can we express that other angle? If their difference is 12, we can express it one of two ways. X minus 12 or x plus 12. Either way works, and I'll go through both to show you. Okay, so if we think of it in this form, we can simply solve our equation. X plus x is 2x plus 12 equals 90. Subtract a 12 from both sides. We get 2x is equal to 78, divide by 2. X equals 2 goes into 7 3 times, with 1 remaining. 2 goes into 18 9 times. So we get 39 degrees for one angle. That means our other angle is 39 plus 12, or 51 degrees. Okay. So here, if we look at this, are these a pair of complementary angles? Yeah, so it confirms that we're good. And now, what if we had set it up as x, and we thought of this as x minus 12. We have the two angles have a difference of 12. We're still going to wind up with the correct answer. The only difference here is when we solve for this, we're going to be solving for the 51 degree angle first, and then we plug it back in. 51 minus 12 would give us the 39. So regardless of which way you choose, you'd get the correct answer in that form. Right. Even though that works, and you're more than welcome to use that, the method I would suggest to use is this next one, and I recommend it because it applies to any problem dealing with supplements and or complements. And that is directly translate the sentence into an equation and solve. Okay, so if you're going to do that, what you need to first do is you need to identify that you're dealing with an angle. We're going to call our angle x. And in this problem, you're dealing with a complement. The complement of that angle is expressed in terms of x as 90 minus x. If we had been dealing with a supplement as well, we would express the supplement as 180 minus x. Okay? So if we look at this as our general, kind of our general legend for these, and we translate our sentence directly into an equation, it says find the measures of two complementary angles if the difference of the measures of the two. So if we say c minus the angle itself, so the difference of the complement and the angle is equal to 12. So if we translate that directly, all we need to do is substitute in our expressions. 90 minus x for c, x for the angle is equal to 12, and then we solve it. 90 minus 2x equals 12. Subtract a 90 from both sides, we get negative 78. Divide by negative 2, we get 39. Plug it back in. 39 is our angle. 90 minus 39 gives us 51, the other angle. Okay. Now, just like with this first strategy, you can still, it doesn't matter which order you put these, you could say the angle minus the complement is equal to 12. Substitute in your values. X minus the quantity 90 minus x is equal to 12. Distribute through. X minus 90 plus x equals 12. Combine your like terms. Add 90 to both sides. Divide by 2. Here we'd find 51 as our original angle. The complement would still be 39. So again, it doesn't matter which form or variation of those that you use, although I would recommend the second one, like I said, because this method of approaching the problem will work for this type of question, which will be considered the most challenging type of question you'll see involving supplements and complements. We start by looking at, we see we have a supplement and a complement. So we begin with an angle as x. Its complement 90 minus x, and this one has a supplement as well, 180 minus x. So here's what we're going to base everything off. And let's translate our sentence completely into an equation. So it says the supplement of an angle, s, is equals 40 more than, so we're adding 40 to some quantity, 3 times the angle's complement, c. Okay, so here's our direct translation. Supplement is equal to 40 more than 3 times the complement of that angle. So all we need to do now is we need to substitute in our expressions. For s, we get 180 minus x. For c, we can substitute in 90 minus x. And that's it. All we need to do now is to solve this resulting equation. Okay, so if we distribute our 3 through, we get 180 minus x is equal to 270 minus 3x plus 40. Let's move all our constants and variables to like sides. So we'll add 3x to both sides to move all the x's to the left. That leaves us with 2x total. Subtract the constant. 270 minus 180 is equal to 90. 90 plus 40 is 130. Divide by 2, and we solve for x completely. X is equal to 65. So we have our solution. If x is 65, then the complement is going to be 90 minus 65, which is 25. And again, if x was 65, our supplement is going to be 180 minus 65, or 115. Okay, let's test this and see if it works. One of the nice things with any kind of calculated problem is you can plug the numbers back in and verify that they work. So if we want to see, is the supplement equal to 40 more than 3 times the angle's complement? So if we take 3 times the complement, 25, that gives us 75, and then add 40 to that, do we get the supplement? Yeah, so it checks, and you should have some confidence that you got the answer right.